Imagine typical Black Friday. Millions of users are flooding your online store, and suddenly the database starts choking. So there's a company. They run a classic e-commerce online store. The architecture looks solid at first glance. EC2 instances behind an application load balancer, an auto-scaling group spread across multiple availability zones. Scaling configured based on CPU utilization. Sounds impressive, right? But there's one big problem. All the transaction logic, all orders, payments, and purchase history is stored in MySQL 8.0, and this database hosted on one single EC2 instance. Yes, it's a powerful instance, but it's alone. Here's what happens next. When load increases, and as usual in e-commerce, it increases unpredictably, the database starts lagging. There's another important detail. The application handles far more read requests than write transactions. Users browse the catalog, view products, compare prices, and only then do they make a purchase. So the company needs a solution that automatically scales for unpredictable read workloads, maintains high availability. Alright, let's look at the options the architects are proposing. Option A. Use Amazon Redshift with a single node handling both leader and compute functionality. Option B. Use Amazon RDS with a single AZ deployment. Configure RDS to add read replicas in a different availability zone. Option C. Use Amazon Aurora with a multi-AZ deployment. Configure Aurora Auto Scaling with Aurora replicas. Option D. Use Amazon ElastiCache for memcached using EC2 spot instances. Now it's your turn. Which architectural solution would you choose? Type A, B, C, or D in the comments. You have 15 seconds to think. Let's start with option D, ElastiCache for memcached with spot instances. Sounds tempting, right? Caching speeds up reads. Spot instances save money. But there are two critical problems here. First, spot instances. AWS can reclaim them at any moment with just 2 minutes notice. For a cache meant to support high availability, that's a disaster. Second, ElastiCache is a cache, not a database. It doesn't replace MySQL. It can accelerate reads for frequently requested data, but transactions, consistency, and ACID guarantees still depend entirely on the database. And most importantly, caching does not solve the problem of scaling the database itself. Option D, wrong. Option A, Amazon Redshift with a single node. Redshift is powerful service, no question. But it's an OLAP system, an analytical data warehouse. It's designed for complex queries over massive data sets. What do we have here? E-commerce project, transactional workloads, OLTP, fast queries like show product, add to cart, place order. Redshift simply isn't built for that. And with a single node, where's the high availability? Where's the automatic scaling for read workloads? Amazing service, but wrong job. Option A, wrong. Option B, Amazon RDS with a single AZ deployment and read replicas. This one is interesting. RDS provides managed MySQL, and read replicas are exactly what you want for scaling read-heavy workloads. But there is a single AZ solution. If that availability zone goes down, your store goes down with it. Yes, the option mentions replicas in another AZ, but the primary write instance still lives in a single zone. And there's no automatic scaling of replicas here. You'd have to add and manage them manually. Option B, close but not enough. And the correct answer is C, Amazon Aurora with multi-AZ deployment and Aurora Auto Scaling. Let's break down why this is the correct approach. First, performance. Aurora isn't just another MySQL. It's MySQL especially redesigned for the cloud. AWS claims up to 5 times better performance compared to standard MySQL on RDS, a huge advantage for high-traffic e-commerce. Second, compatibility. The company already uses MySQL. Aurora is fully MySQL compatible, meaning migration is relatively painless. No application rewrite required. Third, high availability with multi-AZ. Aurora automatically replicates data in 6 copies across 3 availability zones. If one zone fails, the system keeps running. Failover happens in seconds, not minutes. Fourth, Aurora Auto Scaling. This is the key feature. Aurora replicas scale automatically based on load. A sudden spike in read traffic, replicas are added automatically. Traffic drops, they scale back down. Remember the requirement: unpredictable read workloads. Aurora Auto Scaling was built exactly for this scenario. Fifth, Aurora's architecture. Aurora separates compute component from storage component. All instances share a distributed storage layer, so adding read replicas doesn't require copying data. Scaling happens in minutes, not hours. So let's recap the key takeaways. Redshift, great for analytics. OLAP, not transactions. OLTP. ElastiCache, a database accelerator, not a replacement. RDS single AZ, no true high availability. Aurora multi-AZ with auto scaling, a complete, scalable e-commerce solution. If this video helped you, hit like and subscribe the channel. In the next episode, we'll tackle another real AWS exam architecture puzzle. See you there!